Hello everyone, Alan Posner from Throughput Systems. Thank you for joining me for this video, Dell EMC Unity Storage Sizing. So today we're going to look at how we properly size a Dell EMC Unity all-flash array. What are the different elements we need to consider when we're sizing a storage solution? So first we want to think about capacity. What are the usable gigabytes and terabytes that we need, the room we need in order to place our applications onto a storage system? What types of performance characteristics do we require for those applications? And do we have the networking that we need to provide the performance and availability those applications require? So we're going to think about first capacity, right? We want to be able to size for the usable space, and we're going to use a feature called dynamic pools, which is a function of the all-flash Unity in order to create the capacity profile required for the applications. We want to think about performance, right? What kind of performance do we get depending on what type of controller do we use, and what's the impact of using RAID? And we want to look at the different networking interface options and configurations. So let's jump right in. So the factors that are going to influence the capacity with the Unity All Flash. First, we want to consider block size. So every file system and application out there has a default block size or a best practices block size. If it's a Windows file server, that block size happens to be 4K. If we're looking at Exchange or SQL Server, it's 64K. If we look at Oracle, Oracle says it depends. An OLTP app, it could be as little as 2K. A data warehousing type of configuration could be 32K. So we want to be conscientious of the block size of our applications because there's also a block size we need to assign in the pools, in the dynamic pools of a Unity All Flash. We also have some RAID level choices, RAID 10, RAID 5, RAID 6. There's also a RAID width that can be defined. So that's the size of the stripe. So if we're doing a RAID 5, are we going to be doing a 4+1 or an 8+1, for example? That's a choice of what type of RAID width we want to configure. And then data reduction. We're going to want to take advantage of compression and deduplication. So what sort of ratio of data reduction should we expect? So we have to factor all of these in when we configure for our capacity. So let's first talk about block size, right? If the block size of the application and the file systems don't match, two possible outcomes and both of them are bad. Now, in most cases, you may not get an exact match, but you will have some choices to make, and you want to at least make a choice that fits the requirements of your application and has a sensible, common sense, if you will, perspective to it. So if you have very small block sizes in your file system, but you configure very large block sizes in your storage array, you're going to waste a bunch of disk space. If you do the opposite, if you have very large block sizes in your file system, but you configure very small block sizes on your storage array, you're going to make your controller work much harder and you're going to risk not getting any good performance. Now, Unity, fortunately, gives us two block sizes. There's an 8K size and a 32K size. So in most cases, we can get the exact block sizes to match, or we can keep it to a multiple of 2. If we do that, we're going to do well from a performance and capacity perspective. What we want to stay away from are doing things that are multiples of 4. So for example, if I have a 4K write and I choose an 8K block size, that's actually fairly efficient. If I do a 4K write and I choose a 32K block size, again, the latter being for the storage array, then I'm going to be wasting a lot of disk space. And the opposite is also true. If I have 32K writes, or let's say 64K writes from my file system, and I choose an 8K block size, that means I'm going to force the storage array to do 8 writes on the storage array for every single write from my file system. That's not a good choice. But if I'm doing 64K writes from my file system and 32K on the storage array, that's actually a pretty good match. Then it's only 2 to 1. That's efficient. So bear all that in mind. Also, you should know sizing tools will always assume that your application and file system block size match. So choosing wisely is very important. RAID levels. RAID protects your data from disk loss and the penalty is you have to write an additional block. So in RAID 5, you're going to write one additional block of parity. In RAID 6, you're creating these 2 additional blocks of parity. In RAID 10, we're actually mirroring all of the blocks. But your RAID level, although it does impact your capacity, is usually driven by your application requirements. RAID 10 is often selected for database applications because we can get really terrific read performance, and we'll talk about more about that later. RAID 6 tends to be for applications that have low IOP profiles because there's a lot of overhead in creating RAID 6, and so it doesn't typically yield terrific performance. RAID 5 is really a compromise of those two. With only the one additional block, we can still get some pretty good performance out of RAID 5 and still get some good disk utilization. So I feel like I've mentioned dynamic pool a couple of times, and I want to pause for a moment and just talk about what a dynamic pool is, as it's a feature unique to Unity All Flash. So the notion is that RAID is no longer tied to a specific drive. So in this example, if you look on the picture on the right, you can see some green blocks, right? D1, DE1, D2, DE1, D3, DE1, and so on. This is an example of a 4+1 RAID 5, and there are 6 drives here. So it's going to do its 5 writes, and then if we go to orange, you can see that now one of those writes is offset. So rather than having that 5th write in the 5th drive, it's actually in the 6th drive, and so on and so on. The idea being that you no longer need to be concerned with what RAID is tied to what disk drives. Rather, there's an algorithm that manages all of this. All the drives are simply pooled together and virtualized, and then the extents, that's your data, is written out over those virtual pools. And every pool also, just so you know, adds one additional SSD for spare space. There's also no dedicated hot spare any longer. It's a floating spare, if you will. So there's spare space in the pool, which is utilized in the event that one of the solid state disk drives actually becomes unavailable. RAID width is the size of the stripe that you write out. So in RAID 5, you have options like 4+1 and 8+1 and 12+1. So that means that more, greater numbers of extents will be created to write out your particular write operation. Now, the benefit of having a shorter RAID width is you should get better performance. A really long one, because you'll use more disk space, you'll use less disk space, you'll use disk space more efficiently. So that's the attraction of using one versus the other. RAID 10, because it's mirrored, always means it's a 1-for-1 correlation between the primary storage that you've written and the protected copy. One of the big benefits, as I mentioned before, about RAID 10 is that a read operation can happen from either one. And so many times customers who have high IOP requirements for a particular application, they'll create a pool of RAID 10, and then other things like file services or other general purpose applications, they can go on a RAID 5 or maybe even possibly on a RAID 6, and it might be on a small size of RAID width stripe, or it might be a much, much larger one. Data reduction is another important aspect to consider when sizing for capacity. So you could see anything from 1.33 all the way up to 12:1. Flat files tend to deduplicate very well, so we'll often see 3:1 or better. Databases, they can compress and dedupe okay, 1.5:1, 2.5:1. Compressed files like JPEGs or video, you'll see little to no compression or dedupe whatsoever. If you're considering introducing compression and deduplication in your environment, and I encourage you to, I'm also encourage you to try running Squeeze Tool. Squeeze Tool is a way of finding out what will the deduplication rates of my data be before you go and implement this solution, so that way you can make reasonable assumptions and be smart about data reduction estimates before implementing this type of solution in your environment. And if you're interested in that, you just let us know here at Virtuit Systems. Dynamic pool capacity. So I want to give you an example of how dynamic pools work and all the different elements we've just been discussing. So I have 2 pools in this example. The first one is a SQL database. We're going to configure it for RAID 10 because we want that performance. We're going to be very conservative in our data reduction. We're just going to choose 1.6:1. Now again, you might do better. In your environment, you might be getting 2.5:1 on your database. But this is just an example. We're going to choose 64K blocks, and we're going to size for 5 terabytes. Our second pool is just regular file serving. So we're going to choose RAID 5. We're going to choose a 3:1 data reduction. Again, pretty conservative, but very reasonable to expect. 8K block size this time on the storage array on the Unity, and a 20 terabyte configuration. And we're also going to assume that our profile is 80% reads and 20% writes. And we're going to use 1.92 terabyte solid state disk devices in order to create our configuration. So let's take a look at this. So here's our database example, our SQL Server example. You can see 80% reads, 20% writes. If you look on the right, you'll see a 32K block size. And I'm using the 1.92 terabyte SSDs, as I mentioned before. I've got them in a RAID 10 mirrored configuration. And if I use 6 of them in a 2+2 mirror, I get 3.67 terabytes of usable capacity. And if I apply the data reduction factor to it, my effective capacity is 5.87 terabytes, and it gives me about 57,000 IOPS. Right, so this is an example of how I might configure something for a small to medium-sized database application. Looking at it from a storage array perspective, the controller shelf holds 25 drives, the first shelf in a Unity, where all your controllers and everything is managed, but there's room for 25 devices. So here I'm using 6 of the 25. So you can see it's just 2U. I still have a lot of headroom. Now I'm going to go add my second pool. My second pool, same workload profile, 80% reads, 20% writes, but now it's an 8K block size. So if you remember before, we had 32K block size. Now we're using 8K block size because my writes are much smaller with file system than they are with database. Still using 1.92 terabyte SSDs. Now I'm using RAID 5, and with 7 drives, I create a 4+1 stripe, still going to get pretty strong performance. I get a usable capacity of 7.59 terabytes, and if I apply my 3-to-1 data reduction, now I'm going to get actually almost 23 terabytes of usable space. Remember, I needed a minimum of 20, so that's going to be good, and I get about 52,500 IOPS. If I look at that from a storage array perspective, now I have my 2 pools. The blue one is the SQL server we configured initially. The orange one is the file server. 14 drives are used. I still have room for 11 more drives that I can add to the storage array. My usable capacity is about 12.5 terabytes, but because of my data reduction, I'm actually going to get about 32.5 terabytes of usable space total. So what about performance? We've sized for capacity, but how will the decisions that we just made impact performance? So let's look at some of the elements we need to consider in a Dell EMC Unity storage sizing in an all-flash array. So the controller, right? We need to think about what type of CPU it has. So is it a single socket or dual socket? How many cores? What family of processor is it from? How much memory is being allocated? That memory serves as the primary write cache for all of my incoming writes. Reads can also occur out of that memory. And by the way, that's also where all of my services are being facilitated between that CPU and memory. So snapshot, replication, data reduction, anything that I'm doing on the array, resources from those controllers are being used. And they're also managing the varieties of different pools and workloads that I have on the array. What RAID level I choose will also impact performance. We've been talking about mirroring RAID 10 and RAID 5 and RAID 6 and the width, and I'm going to give you some examples of how that changes performance too. And we're going to take a look at workloads, right? The 80-20 workload, which is very typical, 80% reads, 20% writes, but you might have environments that have more aggressive writes, like 67% read and 33% write, or maybe even 50-50. And then I'm also going to show you what a 100% read environment looks like too. So as I mentioned, the controller specifications we want to keep an eye on is how many sockets and how many cores. And it's also good to know what family the processor is from. We can start to assess what kind of horsepower we're going to get from the CPU, how much memory is allocated into the system, and that's also managing all of my network interfaces. So how many network ports do I have and what type of speeds are those operating at? What is different about a Unity all-flash array and about all-flash arrays in general is a lot of performance now is dictated by the solid-state disk devices themselves because they are so fast. And this is different than what we had when we were dealing only with spinning disk. However, aside from this performance of the devices themselves, if you're doing snapshots, let's say every hour or every 2 hours, or at least a couple times a day, if you're running replication between arrays, if you're running compression and dedupe, all of those are attacks on your controller system. And it's important that you have a controller that can handle all those different requirements that you're thinking about applying and taking advantage of those services. If that wasn't the case, you could get away with a very entry-level controller, but in most cases, you need a more powerful controller if you want to use those features. Are you using the system only for SAN, or are you doing NAS as well? One of the benefits of a Unity all-flash is, while it can serve iSCSI and Fiber Channel, it can also do SMB and NFS simultaneously. If you're going to run more services, again, you need a more powerful controller. What type of capacity are we talking about? If you look at the specification sheets of the different models, you'll notice that the managed drive count is much higher on a higher end controller than on the entry level controller. So if you're going to put a lot of data in and you're going to use a lot of solid state disk devices, you're going to want to have a more powerful controller there too. Do you have one pool or do you have a variety of pools? Do you have a lot of different workload types? Again, more workloads, more pools, it's a tax on the controller. So you're going to want to have a more robust controller system for that. And if you have applications that have very high quantities and very high percentages of writes, especially small writes, because all writes get completed at the controller and then moved down and completed down to the solid state disk devices, you've got to have a powerful controller to handle all of the incoming writes. So the controller is still, even though the devices are more flexible because of their performance capabilities than they've ever been before, it doesn't diminish the fact the controller is still a really critical part of your storage array. Very, very important. What about RAID levels? Well, you want to try to pick RAID levels in your pools that are a balance between the workload requirements, the disk space that you need, and the performance that you need. I mean, ideally, I guess it would be great if everything were just configured up as RAID 10, but that wouldn't be a very cost-effective solution and would probably be overkill for a lot of use cases. RAID 6 creates the most overhead. So RAID 6 can be space efficient, but compared to RAID 5, it's less space efficient. It does give you additional protection of data, but there is a performance penalty you're going to pay. RAID 5 is a compromise, and that's probably why RAID 5 is so popular. You do get some data protection from the parity. You can still get some pretty good efficiency because it's only a +1, if you will. You only have that one extra IO. RAID 10, though, for your database applications, mission critical, still the best choice, but does utilize the most space. So now we have three examples, and we're going to compare the file system configuration that we were looking at earlier in a RAID 5, a RAID 6, and a RAID 10. So here, same solid-state disk devices, the 1.92 terabyte SSDs that we were talking about before. And in our first example was the RAID 5 configuration, as we saw before, with 7 drives at a 4+1 stripe. And you can see the 7.59 terabytes of usable space and the effective capacity of 22.77, and it produces about 52,500 IOPS. Now, the RAID 6 example, what's really interesting is we actually have to add a drive to get to about the same usable and effective capacity. It's actually a little bit less because now we have a 4+2 stripe rather than a 4+1 stripe. Now, that is a very small stripe, but even though we're adding an additional SSD, which should give us more IOPS, we actually have less. And we have less because we're always doing one more IOP operation all the time to give us that dual parity protection. Now, what about RAID 10? Well, RAID 10 uses 10 drives. So now, rather than the 7 I have in the RAID 5, I actually have 3 additional. I have 30% more drives, and I have a little bit less usable space. If you look at the usable as well as the effective, they're actually less than the RAID 5 or the RAID 6. But what's most interesting is I have 100,000 IOPS. So even though it's only 3 more drives or 2 more drives than the RAID 6, I have twice the number of IOPS. And that's because I can get a read from any of the mirrors, from any of the copies of the data, and that contributes to the performance profile substantially. And that is the justification for wanting to use RAID 10 with a mission critical database application. I'm going to get terrific performance, and I'm also getting the best availability. So when looking at your workloads, which is what we're going to look at next, high numbers of writes are always going to tax the controller. Any writes that come in and get written to the DRAM, that memory pool in our controller, then needs to be destaged to the solid state disk. So the writes really, really tax the controller. It also should be pointed out, and I don't have it written on the slide, but it also should be pointed out, it does additionally tax the solid state disk device that needs to be proactive and more aggressive in its garbage collection process to create new space for new writes. High numbers of reads are device dependent. So if you're doing a lot of reads and you have quite a number of SSDs, you're going to get the reads directly from those SSDs, and that's really where that performance is going to come from. The cache in your controller can also help with reads, but it's really small and such a small percentage of your entire workload. So again, high numbers of writes, you need a powerful controller. High numbers of reads, you need to have those solid state disk devices of all flash, which are really fast. So again, here are some examples. Now, what I did here is I left everything as RAID 5. So this again is our file system example, same 1.92 terabyte SSDs, RAID 5 configuration. They're the same number of SSDs in every one. So everyone has 7, they're all RAID 5, but what I changed was the workload profile. So the first example is the one that we've been working with, which is an 80% read and 20% write, and it generates 52,500 IOPS. And you can see that on the far right of these columns in this example. But if I just change the workload profile from 80/20 to a 67% read and 33% write, the IOPS drop down immediately to 280, because I'm now slowing the box down as I'm doing more and more writes, making that controller work harder and harder, and making the solid-state disk devices execute more garbage collection processes to free up disk space. If you're not familiar with garbage collection, you can certainly do a search on Google, or drop me a message. There's some contact info below this video. I'm very happy to share some information about garbage collection with you. If we have an even more aggressive application where it's 50% writes and 50% reads, we see the IOPS drop down all the way to 33,600. And if we ever had a circumstance of 100% writes, you can see all of a sudden now we're getting 84,000. So the workload profile is very important. And when you're looking at the storage solution, you need to assess about your workloads. What's the nature? What type of applications do I run? What is it they're going to do? Are they very write intensive? A lot of small block, large block? A lot of considerations when sizing a workload. So last but not least, and I think sometimes this aspect gets a little bit ignored, it's very important to also size for your network throughput. Now, if you're doing NAS or iSCSI, you can look at 1 gig and 10 gig and soon even 25 gig options. And in Fiber Channel, we have 8 gig and 16 gig. Take a look at this chart. I'm not going to read all these numbers to you, but as you can see, Dell EMC gives you the maximum theoretical IOPS per port and the throughput per port for each one of those types of interfaces. So as you're sizing your solution, as you're sizing for IOPS and capacity and all the other elements that we've been talking about, make sure that you have enough ports, not only for availability, and you want to have multipathing, so that way if you lose a connection, it doesn't disrupt the availability of the application, but also make sure that you have enough ports to handle all the IOPS that you're looking to execute in your environment. So this chart right here illustrates what it is for iSCSI and Fiber Channel. And then this chart is if you're running NFS or SMB. You might notice the numbers are a little bit higher with NFS and or SMB. That's really the nature of the protocol and the stateless nature of NFS and SMB versus block protocols. But net is use some factor, some percentage of these numbers, maybe 90%, 80% of this number. Understand that you may lose some of this performance as it goes out into your network and starts going across many connections. But these are still good rules of thumb numbers to think about when building your configuration. So how can you increase throughput and availability? Well, if it's a block protocol like Fiber Channel or iSCSI, you want to think about MPIO or power paths, some sort of path management. So I can have multiple paths coming from the storage array, each controller individually into different switches, and then also have those multiple paths going out to the hosts. If it's SMB or NFS, it's exactly the same thing, only it's link aggregation and file server fail-safe networking. So you want to think about those technologies as well. And one of the things I really like about the Unity All Flash, you can have up to 24 IP ports, or you can do up to 20 Fiber Channel ports. You can also mix and match Fiber Channel with IP ports. So a lot of flexibility, a lot of ports, very easy to size for overall throughput. A fast array needs fast networking. Use these best practices to create the appropriate VLANs and zoning rules, so that way if you lost a connection somewhere because a port died somewhere or an interface card died somewhere, the availability of the system would continue to run and you'd have sufficient bandwidth to be able to serve those applications. It's actually one of the least expensive parts of, and one of the simplest parts of any storage solution, but unfortunately I think it gets overlooked a little bit. So please don't leave this out of your planning discussion. So how do I start? The first thing I would encourage you to do is take an inventory of all your applications by performance and capacity needs. So start thinking about how much usable space do my applications need, and what type of performance profile do I have? What type of RAID level does it probably belong on? And what's the ratio of reads to writes? And if you're not sure, you can talk to us. We can run assessment tools and give you an idea of what it's of what type of profiles you have and make recommendations. We have access to the squeeze tool. We can find out what your data reduction requirements would be. So if you want to experiment with sizings, just ask us. You can contact us also to find out pricing and configurations on Unity All Flash or any of the Unity systems for that matter. Send us an email at sales@virtuitsystems.com or give us a call at 877-VIRTUIT. That's 877-847-8848. Once again, this has been Alan Posner, Virtuit Systems. Thank you so much for watching this video. I look forward to hearing from many of you. If you have any comments, please leave them in the comment section below, and there'll be some links under the video with some details and how you can get in touch with us. Until we speak again, hope you're doing well. Hope to hear from you soon. Thank you so much. Bye-bye.